everybody. Let me start by doing a confession. I am not an Angular developer. Right? Get out of here. But I am going to talk about some things that might be of interest to you, which is authentication with single-page applications. And as you all know, Angular is used to build single-page applications, right? So I'm going to be talking about JSON Web Tokens and single-page applications and how to combine them to do some token-based authentication. Who here has ever used JSON Web Tokens before? Okay, keep them up. Who knows how JSON Web Tokens work? A few less hands. Okay, I hope that by the end of this talk you have a little bit of a better view on how JSON Web Tokens work. If not, too bad. So let me quickly introduce myself. My name is Bellen. I'm from Belgium, and I'm a developer evangelist at Auth0. If you've never heard of Auth0 before, we're an identity as a service provider, which basically means that we try to make it as easy as possible for all you developers to implement a secure authentication flow so you can focus on building your actual products, because that's what we all want to do, right? I'm also a Google developer expert, which means that somebody at Google decided that I know something about something. I organize a few meetups, one in Belgium, Frontiers, which is front-end related, and then an identity and security meetup in London. And if you want to find me on the internet, Sambego is my username in almost all of the websites. Okay, most important slide, I have cat stickers. Who wants a cat sticker? All right, usually I ask you to tweet me a picture of your cat, your dog, your bunny rabbit, but today is special. My girlfriend is Italian, and she lives in a small village not so far from here, and there's this pizzeria called Pizza Ercole. So, I want you all to take a picture of me standing on stage in front of a bunch of Italian people wearing a Pizza Ercole shirt, tweet it to me, and I'll give you a cat sticker. How about that? Okay, cool. So, what we're going to see today, a little bit of traditional authentication, or at least what I consider traditional authentication. We're going to talk about what a token is, and we're going to see a bit about token-based authentication. Sometimes I tend to talk a bit fast, so if I go too fast, just signal me and I'll try to slow down a bit. It's funny because I'm from a part of Belgium where everybody speaks slow, but when I speak English, I tend to speak very fast. So let's get started. Traditional authentication. What do I mean with traditional authentication? Traditional authentication to me is a web app which has the pages generated on the server, right? Like with PHP or some other of the backend languages, they do all the logic on the server, on the backend. They generate an HTML page and send that HTML page to the browser. That, to me, is traditional authentication. So you have the typical scenario: a user visits your website in a browser, the browser does a request to the server handles all the logic and sends back the page. But sometimes the user wants to access a protected page, something he has to log in for. So the user types in his username, he types in his passwords in the browser relays these credentials to the server, and if they match, if they're valid, if the password is correct, we send back the page that the user wanted to have. But we do not only send back that page, we often send back a session cookie as well, because it's annoying if the user has to authenticate over and over and over again to see that page. So we send back a session cookie, so every time the user wants to visit a protected page. After that, we just send the session cookie, and if the session in that cookie is still valid, we give back the page he wants to have. Does this sound familiar to most of you? Perfect. So a traditional web app versus a single page application. A traditional architecture is often browser and one backend. Can be a lot of servers, it can be a few backends as well, but usually the server handles all logic and sends it to the browser. With a single page application, it's not always the case. You might have your single page application, your JavaScript, which runs on a certain domain. And then you might have a bunch of services or APIs that you want to call, be it external or internal APIs, doesn't really matter. So you're dealing with a lot of different origins, a lot of different domains. You can also have a multi-architecture, something like this, like a mobile app, and a web app, and a desktop app, and they all consume the same APIs. Who's working or has worked on something that looks a bit like this? Quite a few hands. Now the funny thing is, the browser and web apps, they use a session cookie to remember the state of your session, but a mobile app is not going to do this because cookies are something inside of a web browser. A desktop app is not going to do this as well. So it would be nice if we had a more consistent way of remembering state, session, and authenticating with your APIs for all of these apps. So maybe we can find a solution for that. So what are some of the problems with a traditional cookie-based approach? Cookies don't like CORS. Who likes CORS? You're lying. Nobody likes course, because if you have a course problem, what you do is you go to Google, you type in, I have a course problem, you end up at Stack Overflow, and you just copy what's on that page. Nobody knows how it works. It's just something that sometimes happens. And cookies also don't like course. A cookie that's issued by a certain origin does not work on another origin. Cookies require state, because usually in a session cookie, you have a session ID, which is somewhere saved in a database together with some other artifacts like an expiry date. But in modern APIs, we try to make them as stateless as possible. So it would be nice if we could have some stateless authentication as well. And cookies don't flow. You cannot pass a cookie from one API to another API. You cannot pass the contents of one. In theory you can, but you should not. So they don't really flow from service to service, from API to API, from backend to backend. Like so. So what's the solution? Maybe it's token-based authentication. We'll see about that later. But first, let's talk about tokens. What is a token? Anybody have a guess or have an idea what a token is? You can go ahead. No? Okay. My definition of a token is a unique identifier representing something. Basically, you take a token, and based on that token, you can distract or distill some meaning. So it's a session ID that just verifies or that identifies an ongoing session that you saved in your database. It might represent some identity as well. So a token is something that represents something to you, and you can get some meaning out of that token. And there's a few different kinds of tokens that I want to be talking about today. An access token. Who's used this before? Okay. An ID token. A few less hands. Refresh tokens. You should not use them when you're using single-page applications, but more about that later. And they're often an opaque string in the form of a UUID, which means that they're a bunch of random characters that form a unique identifier, but they don't really mean something except that you save them somewhere in the database with some other attributes. But they don't have to be. If you're using SAML, they're a bunch of XML, which has a bunch of information inside of that XML file. But SAML is a bit outdated. If you're still using it, for you. And there's this new standard called JSON Web Tokens, because we prefer JSON on the web these days over XML. And that's what I want to be talking about today as well. So JSON Web Tokens. Not zero use them as much as possible for the only reason that we like them and they're very convenient. And this is a JSON Web Token. And as you might see, it looks like a bunch of random characters, some random data. But it's actually made out of 3 different parts with a dot in the middle. Who's ever noticed that a JSON Web Token is made out of 3 different parts? Very good. Okay. So a JSON Web Token is made of 3 different parts, and the first part is called the header. And what the header basically is a base64 encoded JSON object. JSON Web Tokens, it's going to be a lot of JSON. And it can look something like this. And what this is just some metadata about your token. It says the type, it's a JSON Web Token, and it says which algorithm has been used to sign that token. More about signatures later, but you already know which algorithm you're going to use to verify the signature of the token. The second part is called the payload. This is usually the biggest part. And again, this is just some base64 encoded JSON. If you would decode it, it would have a bunch of different claims. A claim is a key value pair, which has some meaning to you, which are of interest to you. So this can be some identity-related information. This can be some scopes or whatever if you want to use it with an API. But it can also contain the expiry date and the issue that date. So no need to save the token somewhere in the database together with an expiry date. The token can contain its own expiry date right inside of the token. And then there's a bunch of different claims. The first set of claims are called reserved claims, and these are basically just claims that are specified in the spec of JSON Web Tokens. Subject, that's your user ID usually. The issuer, the issue that date, the expiry date, and a few others. Then there's public claims. And these are claims that are not really standardized in the spec, but are standardized by IANA. IANA is an organization on the internet that just standardizes stuff. And they have a list of all different claims that they standardize just for API interoperability. So if you make an API, my first name will be given name. Don't know why not first name, but it will be given name. Just so you know that all APIs give this data in the same way. All right. The last set of claims are private claims, and this is basically everything that's interesting to you. As long as it's valid JSON, you can put it in there. But do remember that it's just a base64 encoded JSON object. So don't put anything sensitive in there. Don't put credit cards or anything else in there. Okay. The last part is called the signature. And basically what you do is you take your header, you take your payload, you run them through a signing function. In this case, it's HMAC, and you get back a signature. But because we use a header and a payload inside of this function, if you change something to that header or you change something to that payload, you're also going to change your signature. So based on the signature, you can verify that the payload, that the header has not been modified in transit. JSON Web Tokens can be verified. You can be sure, based on that signature, that it's still a good JSON Web Token, that nobody has stolen it, change some things, and then send it back to you. Usually, you use something like this as a secret. Of course, not just the word secret. So if you see this in practice, you take a base64 of your header, base64 of your payload, sign it, and if you would paste these three parts together, we have a working JSON Web Token. If you go to JSONWebToken.io and paste it in here, you can see that we have the payload data that we just base64'd in there, except there's a space missing in my name because I'm sometimes a bad programmer. So a JSON Web Token is just header, payload, signature, that's it. But some real-world examples because it's all a bit abstract, right? An access token. A lot of you have used an access token before, and an access token is something you send to an API to access something that is protected in that API. And it can look something like this. It's issued by this authorization server. It's about this subject, so this user. The audience, which API that's going to consume this, is issued at and expires at this date or this timestamp. The access token grants this kind of scopes, these scopes to be accessed on the API. So it contains a lot of information about accessing an API and stuff like this. An ID token, on the other hand, is more concerned with identification, with identity of the user that just authenticated. So it's going to contain a lot of personal information like my nickname, my name, my picture, so I can have a profile picture inside of it, and again, the expiry date and things like that. And we've seen that you can sign them within a signing algorithm that uses a secret key, but there's also asymmetrical algorithms. A bunch of them, all of these at the bottom. And they don't use a secret, they use a private key and a public key. Use a private key to sign, I use a public key to verify the signatures. And if you want to share these public keys, you can do this in a lot of ways. And one of them is with a JSON Web Key. JSON Web Token, JSON Web Key. It looks a bit like this, basically some JSON that contains some public key information that you can use to verify a signature. You cannot create a new signature with this, you can only verify a signature with this. And this is often shared under the well-known URL of your authorization server, and if we would go to that, or I think I have a video, you will find a lot of information about your authorization server, but one of the things in there is a JWTs URI, which is basically just a URI where you publicly make available all the public keys that people can use to verify your signatures, like this one. So JSON Web Token, I don't think you can read the OKen, but JSON Web Token, JSON Web Key, JSON Web Signature, it's basically the bottom part of a JSON Web Token. JSON Web Encryption, if you want to encrypt your token, you can use JSON Web Encryption. I'm not going to be talking about it because I don't have that much time. But there's a lot of standards based on JSON for encryption and signatures and doing stuff on the internet based around security. So let's make a little comparison. On the right side, you have a Belgian password written in 4 languages because we might like to make it a bit more difficult. But what it says is, I'm a passport by the Kingdom of Belgium from the European Union. And it's basically the same like the header of a JSON Web Token. It says, I'm a JSON Web Token, and I use this algorithm to sign myself, or somebody has used this algorithm to sign me. If you open the passport, it contains a lot of information about myself, my picture, my name, my nationality, and also an expiry date, which is kind of the same thing as the payload of a JSON Web Token. It contains some information that is of interest to access either an API or to some identity of a user, and it contains an expiry date as well. And then there's a signature in the JSON Web Token, and most passports, I think all of them, have some ways of verifying that they're not fake passwords like 3D holograms, UV lighting thingies. stuff like that. So in essence, a JSON Web Token can be seen as a passport to access APIs to get some information about the user. So let's see it in action. I have this amazing app right here, which has two functionalities. It can show you dog pictures, because dogs are cute, right? It also has this other button to show you cat pictures. But when I click on it, cats are a bit more difficult. They don't want to be seen that easily. So it says no authorization token found, which means I have to log in. Conveniently enough, I have this big login button. But I don't know if we have internet. We don't. That's okay. I have a video of this. I can prepare it. So we have dog pictures, and every time we click the button, we get a dog picture. If we click on the cat pictures, it doesn't work. We'll have to log in. We log in with Google, because that's very easy. And once we've logged in, we can get some cat pictures, because now we got an access token and an ID token. And because we got this ID token, we can immediately show some identity information in the top right corner, like my profile picture and my username. Without doing an extra request to user endpoint, we got back an access token and an ID token. And by looking inside of this ID token, we know that my username is Bellen. My picture can be found at this URL. We know a lot about my identity, which is very nice. If you would look at this from an API kind of perspective, I think I can show this in real life. Okay, so we have this. Can you see this in the back? We have this authentication request, which is basically just going to send my username and password. Don't use password as a password, obviously, to this endpoint, and we get back a JSON Web Token. If we copy this for later, we have our public docs request, so that's just API/docs, and we get back a random dog picture, like we've seen before. But if we want to do this for cats, we get a timeout. Oh, no, I changed this. Let me quickly. No authorization token was found, because we have to give an authorization token as a bearer token. So if you would pass along the one, oops. If we would pass along this token as a bearer token, we get access to a cat picture, right? But it doesn't stop here. This is very normal procedure that if you pass a valid access token to an API, you'll get access to whatever you're requesting. But one of the strengths of a JSON Web Token is that it contains a lot of information inside itself. So if I would pass along a JSON Web Token that is expired, of which the expiry date is in the past, without doing some more lookups, I would know that this token is expired, and I don't have to accept this token just because the expiry date is inside of it. The same thing goes for a token that is not valid anymore because somebody tried to change something in the payload, so the signature doesn't match the header in the payload. If we try to use one of those, we get an invalid signature, and we don't accept this token. So, but without doing a lot of extra lookups, by just using a JSON Web Token middleware in our API, we can already catch a lot of cases where the token is not valid. Presentation. Okay. If you want to know more about JSON Web Tokens, there's this website called JWT.io, JSONWebToken.io. It's built and maintained by me and Auth0, just as a disclaimer. And we've seen it before. It basically has a debugger, which you can use to create or debug JSON Web Tokens. We don't send any tokens you paste in here to a backend. We don't save them. They're kind of secure. Everything is handled in the front end. And it also contains a list of libraries that help you use JSON Web Tokens. And since we're in JavaScript, there's a few JavaScript libraries as well. Okay, so are there some downsides to JSON Web Tokens? Yes, invalidation of tokens is a bit harder because it contains all the information inside of itself. Once a token has been issued, it stands on its own. So if you want to revoke a token, you either have to go with a blacklist or a whitelist. So you check that blacklist or whitelist first before checking the validity of the token itself, just in case you want to revoke a token. If you leak your secrets or private keys, that's going to be an issue. That's why they're called secrets and private keys. You have to keep them as secure as possible. And please don't put sensitive data inside your JSON Web Token. It's just base64. We all can go to base64decoded.com and just paste it in there and see what's inside of it. So think twice when you put some data inside of this. Last part, token-based authentication. The same scenario, user browser server. The user wants to access a protected page. It's going to send its credentials, log in with username, password. And if they match, we're going to get back our data. And instead of a cookie, we're getting back an access token. Very straightforward. Who's used this before, this scenario? A bunch of you. OK. So in the first example, we got back a session cookie. Now we get back an access token. We save this access token somewhere in memory. And we use it every time we want to access that protected resource to get the data back. If you want to do this in JavaScript, it's just basically sending the authorization header in your request in Angular, because with an Angular conference, you just use the http.get method and then add some new headers, which has the authorization header inside of it, and you pass along your access token. So who's ever used OAuth before? A lot of hands. OAuth 2.0 is a protocol that allows the user to grant limited access to the resources. So what it's meant for is to grant limited access. It's not meant for authentication, it's meant for authorization. If you want to make your API or part of your API available to some other party, to other resources, that's when you're going to use OAuth. If you want to do a token-based authentication, on the other hand, you're going to use something like OpenID Connect. Who's ever used OpenID Connect before? Few less hands. Chances are that a lot of you who've used OAuth before are actually doing authentication as well and doing part of OpenID Connect, because OpenID Connect is ORDC. OpenID Connect was created as an identity layer on top of OAuth 2.0. So you take everything in OAuth and just add the ID tokens, the identity layer on top, and you have OpenID Connect. So it's a bit more a complete framework to do authentication and authorization with tokens. And it looks a bit like this. I've split my authorization server from the rest of my API for convenience. But again, we send our credentials to the authorization server. If they're OK, we get back our access token. But we can also get back an ID token, a token that contains identity information, and a refresh token if you really want to. And we save them somewhere in memory, and then we use the access token to access our API whenever we need to. But does this mean that the user will have to log in every visit? Because I've said we save these tokens in memory. You should never save these tokens somewhere persistently, not in local storage, IndexedDB, cookies, whatever you have, session storage, because they're very vulnerable to cross-site scripting. Who uses npm to install libraries? I think I can see all hands, right? Whoever looks inside of these libraries, which code is actually inside of them? I see 5 people who are lying. If not, that's very good of you, but almost nobody looks inside of them. So every library author can easily put some piece of code in there that just looks inside of your local storage and steals everything that's inside of them. So never steal your cookies, store your cookies somewhere persistently, keep them in memory. And then when the user logs in the first time, you send your credentials, you get your tokens back, but you also get back a session cookie. So we're back to the beginning. And the next time the user visits, we will do a silent request in the background, usually in an iframe, with this session cookie. This iframe contains a page that has the same origin as our authorization server, so we don't run into coarse problems. And if the session cookie is still valid, the session inside of the cookie is still valid, we send the tokens back to the application and post them from the iframe to the main application. This means that you get new tokens every time your app bootstraps. This should be done as soon as possible, so you can go ahead with using your tokens. But every time you refresh or the user revisits your website, you're going to request new tokens, just so you don't have to save them somewhere persistently. And then you use them. This is using the OAuth implicit flow, and the IETF, the Internet Engineering Task Force, published a new best practices document, I think in December, to not use this anymore if possible. And they recommend the authorization code with proof key for code exchange PXE flow, which is PXE for short. And it's basically the same, but when you authenticate, when you do your username and password, you also send along a code challenge. The authorization server is going to save this code challenge and send back a code. Then you sign this code in some way and send it together with the code verifier, which is the signed code back to your authorization server. And based on the first request, the initial code, and the code verifier, you can kind of figure out that they're signed by the same private key. You can verify that the client that initiated the initial request is the same as the one who is going to get the tokens. So it's a bit more secure. It solves a few of the the issues with the implicit flow. This doesn't mean that you have to start changing all your apps, because most apps these days use the implicit flow, at least single-page applications. But if you start a new app, have a look at the Pixie flow, and then you get back your tokens. A note about access tokens is JWTs. I think I still have a bit of time. OAuth and OpenID Connect do not specify what format an access token should be. They don't have to be JSON Web Tokens. An access token can be anything. It can be UUID, it can be a JSON Web Token, it can be anything that's a token to you. But there's an IETF draft by one of my colleagues that kind of specifies how to use JSON Web Tokens as access tokens, just to have some the same way of doing this across all organizations and apps. ID tokens, on the other hand, are always going to be JSON Web Tokens. That's because in the spec of OIDC, OpenID Connect, it is stated that an ID token is always going to be a JSON Web Token. And as lastly, a note about refresh tokens in single-page applications. Using refresh tokens in the front end should be avoided unless a system of refresh token rotation or sender constraint is in place. So unless you are able to rotate your refresh tokens on a very regular basis, which most identity services do not do yet, or you can do sender constraint, which basically means that you can match the sender of a token to the receiver, which is something very theoretically possible, but in practice it's not possible because there's no way of doing this yet in the browser. So unless you have something that's not very available or something that's not possible in place, don't use refresh tokens with single-page applications. Just so you know, it's not a good idea, because if you lose a refresh token, everybody can just create new access tokens, and that can be disastrous. So does this approach solve CORS? Who thinks it does? A few people. I should see a bit more hands. As long as you know how to verify a JSON Web Token, you can pass it along from origin to origin. It's not issued like a cookie by a certain domain or a certain origin. As long as you know how to verify them, you can use them in any API, any domain, any service you want. Does this approach solve for flow? Who thinks it does? Few hands. Again, as long as you know how to verify them, you can pass them along from service to service, from API to API, as long as they're in the audience of your access token, for example, and they know the shared public key or the shared secret, you can use them. Does this approach solve keeping state? Who thinks it does? And in theory, a few hands, in theory it does, but if you want to keep a blacklist or you want to do the silent request in the background to get new tokens every time your user visits, you still need to send a session cookie, which means you need to keep a session database as well. So in theory, yes, but because some clever hackers who misuse the JSON Web Tokens, we have to find ways to prevent that, and you still need a bit of state. So let's summarize. Using session cookies is hard with single-page applications, mostly because of CORS and other things. We use multiple APIs. Status authentication is possible if you don't want to blacklist or you don't want to silent authentication. And JSON Web Tokens consist out of 3 parts: the header, the payload, and the signature. If you want to know more, JSONWebToken.io. WebAuthn.me is something about the Web Authentication API. If you're interested in that, it's a very new W3C standard about authentication, but public key and private keys. Our blog has a very good overview on what's wrong with the implicit flow and why you should use the Pixie flow instead, and some other great articles as well. If you want to see these slides again, jwt.sambego.tech. They're more or less the same slides. I might update them later. These should be gone. Thank you.